Hey everyone, today we're going to talk about geometric sequences. So the difference between a geometric sequence and an arithmetic sequence is that arithmetic sequences you have to multiply or divide by a value to get the next term. Remember, arithmetic sequences you had to add or subtract by the same number to get the next term. So in geometric sequences, since we're multiplying or dividing by a number to get the next term, the common ratio is the number that you have to multiply to get the next number. So like when we're looking at 2, 4, 8, 16, so on and so forth, every time I had to multiply by 2. So since I had to multiply by 2 every time, my common ratio is going to be 2. These should be commas right here. So we have 4, then 2, then a half, then, oh no, I did not do that. I need to have a 1 in there first. There we go. Much better. Okay, so now we have 4, 2, 1, a half, 1/4. So every time I'm dividing by 2, but I have to think about it of what I'm multiplying by. So that's the same thing as multiplying by 1/2. And then from 2 to 1, we multiplied by 1/2. And then from 1 to a half, we multiplied by 1/2, so on and so forth. So our common ratio there is 1/2. So to find the next term or the nth term of a geometric sequence, or the explicit formula for a geometric sequence, it's going to be this guy right here. So this is, remember, just my term. This is my nth term, whatever number is there for the n. Remember, a sub 1 is my first term. R is my common ratio. And n is my term number. So once again, we have that n minus 1 inside of our formula. Don't worry, all of this is going to be in your IB notebook, IB kiddos. All right, so given this sequence, we want to find the common ratio, the explicit formula, and the 10th term. So first, to find the common ratio, we want to figure out what do we have to multiply by from one term to the next. Well, from 3 to 6, we had to multiply by 2. Same thing from 6 to 12, and from 12 to 24, so we multiplied by 2 on both sides. So that's R, my common ratio, on both sides for each term. Sorry, I'm getting used to solving equations right now. Okay, now to find my explicit formula. So I have A sub n equals. Now we can see here that the first thing I'm supposed to have is my first term. And my first term here is 3. So we'll have 3 times. And then R, my common ratio, which we already decided was 2, and that's to the n minus 1 power. So you can write it like that. Or some people like to write it with parentheses around that too, which is totally fine. Another way to write that is 3 parentheses 2 to the n minus 1. Good deal. Now we want to find the 10th term. So to find the 10th term, we're just going to plug in 10 for n. So I'm going to have 3 times 2 to the 10 minus 1. So we'll take 2 to the 9th and then multiply that by 3. And that will end up being 1,536. Good deal. Okay, now we want to find the explicit formula of the geometric sequence described. So my second term is 3, and my fifth term is 24. So we're going to think through this the same sort of way we did with the arithmetic ones, about how my fifth term is equal to my second term, and then my common ratio happens 3 times between a sub 1 and a sub 5, right? So to get a sub 3, a sub 4, a sub 5. So we needed that common ratio three times. But here's what's happening. We're not adding that every time, right? We're multiplying by the same number every time. So I need to take a squared times r times r times r. So since I have that repeated addition, or I'm sorry, repeated multiplication, that's why I have a power. So if we look back at this nth term, that's why we have a power right here, because we have repeated multiplication. All right, neato. So we're going to plug in what we know. We know that a sub 5, my fifth term, is 24. We know that a sub 2, my second term, is 3, and then I multiplied by r 3 times. So r times r times r is r cubed. So now to solve for my common ratio, we'll divide by 3 on both sides and get 8 equals r cubed. To get rid of that cubed, we'll take the cubed root of both sides. So r is equal to 2. All right. So we already know what the second term is. Now we can go back and find the first term. Now we know we had to multiply by 2 to get from the first term to the second term. So to go backwards, I'm going to have to divide by 2. So my first term is 3 over 2. Good deal. So for my explicit formula, sorry, my computer. There we go. So for my explicit formula, a sub n equals, my first term is 3 over 2 times, my common ratio is 2, and that's always to the n minus 1 power. Okay, go ahead and try that next one on your own. Common ratio 3 times. So then we plugged in what we knew for a sub 3 and a sub 5, and then took r times r times r and made that r cubed. And then we solved for r and got 1.5. So we knew that our, oopsies, that is not my first term. I made a mistake. Let's try that again. So what I just found, that is not the first term. I took 9 divided by 1.5, and I got 6, but that was actually my second term. I'm sorry. Now we need to take 6 and divide it by 1.5 again. So a sub 1 is equal to 4. So a sub n should equal 4 times 1 times, or 1.5 times, or to the n plus 1, or n minus 1. Oh my goodness. 4 times 1.5 to the n minus 1. Good deal. Okay. This next one. So my fourth term is 125. My 10th term is 125 over 64. So here's what we know. We know that my 10th term is equal to my fourth term times the common ratio happening 6 times, right? So instead of writing out times r 6 times, I'm just going to put it to the 6th power. Okay. So we know this is 125 over 64 equals 125 times r to the 6th. We'll divide by 125 on both sides. So we'll have 1 over 64 equals r to the 6th. Then we'll take the 6th root of both sides, and we'll find out that r is equal to 1/2. Okay, so we knew that our fourth term was 125. So then we'll divide by 1/2 to get the third term. That'll be 250. Then we'll divide by 1/2 to get the second term. That will be 500. And then we'll divide by 1/2 to get the first term, and that will be 1,000. So let's go ahead and write this out. A sub n equals, my first term is 1,000, times, my common ratio was 1/2 to the n minus 1 power. Okay, good deal. See you later.